Welcome back students. In this video we are going to study about dihydrogen, which is gas, which is actually a colorless, odorless gas. It is highly flammable. So we'll study its preparation, properties and uses in this video in more detail. So let's start. Dihydrogen. Okay, the first question is that how dihydrogen is prepared, or how is dihydrogen prepared actually, and what are the methods used for preparation of dihydrogen. And the first method which is used for preparation of dihydrogen is by reaction of water on metals. Actually, some metals are more reactive, some metals are less reactive. So more reactive metals react with hydrogen, with water at room temperature only. In fact, they react vigorously, that means so vigorously that hydrogen is produced and that hydrogen catches fire. So that is why they are actually harmful also, they may cause accidents. While some other which are not so reactive, they need to heat the mixture in order to reaction take place. So sodium reacts with water to give sodium hydroxide and hydrogen. Similarly, calcium also reacts with water to give calcium hydroxide and H2, and so is potassium to form potassium hydroxides and water. Actually, these metals are highly reactive and the reaction is very vigorous. I just told you it is so vigorous that what happens, it catches fire sometimes and may cause accidents. That is why we use, most of the time we don't use pure sodium, but we use amalgam of sodium. Amalgam means sodium along with mercury. Okay, the next question is, we have just discussed that how very highly reactive metals react with water, and there are some metals which are not so reactive like magnesium, aluminium, zinc. So they do not react at room temperature, but they react with boiling water, and the reaction looks like this. Magnesium reacts with water at high temperature to form magnesium oxide and hydrogen. Similarly, zinc also reacts with water at elevated temperatures to give zinc oxide and hydrogen, and we can say aluminium also reacts in the similar way with water at elevated temperature to give Al2O3 and water and hydrogen. Okay, but metals like iron, they react with steam at high temperature. That means they are so unreactive with water that they do not even react with boiling water, but they react with steam, and like the reaction is like this. What iron reacts with water, gaseous water or steam to form iron oxide, and this process of reaction of iron and steam is known as Lenz's process. And this is how dihydrogen is prepared on laboratory basically, and it is prepared by this is laboratory preparation of metal of hydrogen. And this what is done, metal, and more generally it is zinc reacts with sulfuric acid to give zinc sulfate and hydrogen gas. So this is the laboratory preparation of hydrogen gas by action of zinc or any other metal with sulfuric acid. Okay, and the metal like zinc, aluminium, etc., they are used for this process. Now next is electrolysis of water. This is how actually hydrogen is prepared on an industrial scale by electrolysis of water. What is done, that we have water. This water is electrolyzed to give hydrogen and oxygen, and there are two different reactions taking place at this reaction takes place at cathode, in which water takes electron to form hydrogen and hydroxide. At anode, this hydroxide ion is released converted into water, oxygen, and electron is released. So this is electrolysis of water. Now there is another process which is used for industrial preparation of hydrogen known as Bosch process. In this, what is done in the first step, that carbon containing compound, or let's say coke directly, is treated with we can say water. Coal is treated with water at 1270 Kelvin to give carbon monoxide gas and hydrogen gas. And this is a mixture of gas which is known as water gas. This is called water gas, and this water gas can also be prepared by action of water or steam over any compound containing carbon or hydrocarbon. Let's say CnH2n plus H2n plus 2 is the formula of an hydrocarbon. When it is treated with n molecules of water at 1270 Kelvin, it forms n number of molecules of carbon monoxide and 2n plus 1 molecules of hydrogen. With an example, we can understand it like this, that CH4 reacts with water molecule to form carbon monoxide and 2 hydrogen molecules. Okay, so this is the first step of Bosch process in which we produce water gas. Next process is actually separation of hydrogen from the water gas, and this is done by action of this water gas. This water gas is mixed with steam and it is passed over heated iron oxide or chromium oxide at 770 Kelvin. So what happens, that carbon monoxide is converted into carbon dioxide. That carbon dioxide is soluble in water, so it is whenever this mixture is further passed in water, carbon dioxide being soluble dissolves in water, while hydrogen insoluble escapes away, which is collected. So what this is like, the reaction is like this: hydrogen, carbon monoxide, steam, Fe2O3 and Cr2O3, we get carbon dioxide and then hydrogen, and when this mixture is passed into water, this gets dissolved and this escape away, and this is known as water gas shift reaction. Now, physical properties of dinitrogen, we are well aware of the fact that it is colorless, tasteless, odorless. It is extremely insoluble in water because it is non-polar. Its density is 1/4 to that of air, that means it is lighter than air. In fact, it is the lightest substance known. It can be liquefied at high pressure and very low temperature. It is highly combustible and should be handled with care. And if we talk about chemical properties, first of all, it is neutral, neither acidic nor basic. Combustibility, it is highly combustible and it burns with air with a pale blue flame to form water. Reaction with metal, actually it reacts with metal to form hydrides, just like sodium reacts with hydrogen to form at 525 Kelvin to form sodium hydride, 2 molecules. Similarly, calcium reacts with dihydrogen at 525 Kelvin to give CaH2, and here the oxidation state of hydrogen is -1. And in case of what happens, that metal like platinum, palladium, nickel, they have interstitial space in crystal lattice like this space, and hydrogen can fill these spaces to form interstitial compounds, and this is known as, the special term is used for this, which is occlusion, and the occluded hydrogen can be liberated from the metal by strong heating easily. Okay. Now, reaction with metal oxide, we are very well aware of the fact that hydrogen is a strong reducing agent. So what happens, that when metal oxides like copper oxide is heated with hydrogen at high temperature, we get copper and water. Similarly, when Fe2O3 is heated with hydrogen, we get Fe 3 molecules and then water molecules 4, and the hydrogen would be 4 also. So this is how hydrogen acts as reducing agent for metal oxides. And there is another method which is chemical property, which is known as hydrogenation of vegetable oils, and it involves the conversion of unsaturated hydrocarbons into saturated hydrocarbons, or we can say the conversion of liquid into solid fat, or conversion of vanaspati oil into vanaspati ghee. We have CH2 double bond CH2, which is an unsaturated hydrocarbon. Into this we pass hydrogen gas in the presence of platinum or nickel at 473 Kelvin. The 2 hydrogen goes one at this side, one at this side, and we get CH3. So vanaspati unsaturated to saturated, vanaspati oil to vanaspati ghee, and this is known as hydrogenation or hardening of oil. Now, uses of dihydrogen. Dihydrogen is used in various industrial processes, like it is used for preparation of ammonia, which is further used for preparation of various fertilizers like ammonium sulfate, urea, calcium ammoniate, ammonium nitrate, etc. It is used for hydrogenation of vegetable oils. It is used in manufacturing of synthetic petrol. Oxyhydrogen, it is used in oxyhydrogen torque for welding if the temperature required is above 2500 degrees Celsius. It is used in atomic hydrogen torch for welding if the temperature required is around 4000 degrees Celsius, and the liquid hydrogen mixed with liquid oxygen is used as rocket fuels in space programs. Now there is a question that in Bosch process, which gas is utilized for preparation of hydrogen gas? So the first step is that hydrogen is treated with water, steam actually, at very high temperature like 1270 Kelvin, and we get mixture of carbon monoxide and hydrogen gas, and this is known as water gas. So correct option is water gas, B. Students, in case you have any doubt in this topic, you can post that question in our discussion board. For that, all you need to do is to go to the home page of Ask IITians. There you will find an option of discussion board. You have to click there. Then in the right side, you will find a portion of Ask Experts. In that, just select the category in which you want to post your question. Let's say it's physical chemistry. Then post your question here, and then if you want to attach any image, use this option to attach the image, and finally post it by clicking on Get Answer, and you will be answered within 24 to 48 hours by our experts. So students, we studied about physical and chemical properties of the gas dihydrogen, and we also studied about its uses and how to prepare it in laboratory and on industrial scale. Now next video we'll move to a compound of hydrogen which is very important for us, and that is known as water. So stay tuned.